formally calling on groups.
Call on group 6.
Tyler, you choose Tyler.
Number 1, group number 1. What'd you guys get? Those would be the zeros. Emily, you're totally right. What was the factoring before that?
X minus 9.
Yeah. Good. Okay, now quick heads up. Read the directions one more time. What did they technically say? You didn't actually have to keep going. But good practice. But if I were you guys, because some of you might have kept going, I know, I led you up to it saying it's good for zeros, but read the directions, just factor. Box the factoring, don't box the zeros. If something says to factor, don't keep going. Okay, number 2. Group number 8.
Maybe x minus 7 and x plus 2.
Yes, almost. I like.
Oh,
Thank you. There we go. Oh, man. Some things you never grow out of. All right, so p minus 7 and p plus 2 are my factors. Perfect. Group number 4. Number 3.
M plus 8 and M plus 1. Wait, what? Oh, minus 8 and minus 1.
Why?
Because you have to set equal to 0.
No, not yet, Jane. If we needed to find the zeros, we would. It would be negative 8 and negative 1 from your factors. But look back at your quadratic real quick. Rest of group number 4. Help out. Why are the pluses not right?
Because they don't have your negative.
If you FOIL, you get m squared plus 8m plus 1m plus 8. 8 plus 1 would be a what 9? So to make a negative 9, we're just going to change one thing. And what's the one thing? Those signs. Tricky little stinkers. There we go. Is that better? So we have to keep, now this one was perfect, because to get a positive 8, they are the same sign, and the positive would have worked. But to get the negative 9, we have to have the outer and inner be negative. So then if we found the zeros, it would be a positive 1 and a positive 8. Okay, nice. Those signs always get tricky. Number 4, group number 5.
Yeah, that means we have a good chance.
x minus 7.
Why both minus based on the last one? Because the middle term is negative, and the last term is positive. So I need 2 negatives to multiply to be a positive, and 2 negatives with the outer and inner to make the negative middle term. Do you guys all agree?
Yes, call group 6 now. You should call group 6.
Are you sure? Number 5. Did you like it?
Yes.
Some yes, most no, and the no's just aren't saying anything.
investigation. I didn't.
It was a good investigation to explore a little bit, right?
Yeah, you have to go and
Group number 6.
Yes.
What's number 5?
7x. Caleb, I'm the spokesperson.
Whoa, man.
7x plus 4, x minus 5.
Tyler,
How you do that?
I'm just curious, how'd you do it?
Well, multiplied 7 by negative 20, found 2 factors, which added, oh, sorry guys, too quick. Found 2 factors, which added to negative 31, which was negative 35 and positive 4. Then you did it wrong. And then I did
That was very brutal.
You deserve a smack right there. Don't actually do it, I'm not
put
endorsing
it
it, but still.
into a
Which one was negative, which one was positive?
the 35 was negative.
Because
Does it add to add for,
has to add to be a
yeah.
negative 31. Okay, then what, Tyler?
Well, I don't know how to say it. I put it into.
Good.
I split up the middle term.
Good. Good. Into, did you write the 4 one first or the negative 35 one first?
Negative 35.
I would have done that too, and I'll explain why in a second. Keep going.
so I don't kill a seal.
Basically, yes, that's exactly
And
right.
then I took out the greatest common factors of, I grouped,
Uh-huh.
and then from that took out the greatest common factors.
Which for the first one was a 7, yeah?
Yeah.
Uh-oh.
Oh, no, 7x.
Yeah, we don't want to keep the x in there because that's messy, but a 7x. And then a
4. And then take out the greatest common factor. And then,
what's left? 7x plus 4. How many of you guys remember doing this grouping thing in sometime in your past? Oh, that's it?
I remember doing this.
There's like over half of you, so I'm guessing both classes did it at least a little bit. Doesn't mean it was your favorite thing ever. Technically, there is a way of guessing and checking and just like starting here and like randomly filling in stuff until you can find the right combination. But this is a nice systematic approach. Now hold on. Uh-oh.
What? What else?
Let me start at the beginning and explain. Is that okay? Number 5. What's the part that we don't like?
The 7.
The number in front, right? It makes everything worse.
She messed everything.
But how do we deal, I would say, every time to have a systematic approach? Like if you don't naturally go here and end up here, somehow, using whatever method you've done in the past. If you can't get from here to here, we gotta have a new method, okay? And the systematic approach is to say, we used to just look at the last number for all the ones up above, 1 through 4. Didn't you guys look at the last number? Think about factors and which ones add or subtract to be the middle number, right?
Yeah.
Okay. But as soon as we have a number in front, we have to actually look at factors of A times C or first times last. So then Tyler took 7 times negative 20, which is negative 140. And I just started finding factors, but how? I said 1 times what? Divide by 1. 2 times what? Divide by 2. 3 times, 3 didn't go in. 4 times what? Divide by 4, it's 35. And I'm looking for anything that multiplies to be 140, but can add or subtract to be 31. Now, I wasn't worrying about signs. I was just looking at 1 and 140 can never add or subtract to be 131. It'd be 141 or 139. Yeah, no. 2 and 70 would either be subtracting 68 or 72. Positive or negative doesn't really matter. It doesn't make 31. This one, though, 4 and 35 can subtract. And if I have a negative middle term, that means the bigger one had to be negative. The other one had to be positive because a negative times a positive is a negative. Then we take these two. They were kind of our winner chicken dinners. We brought them over and we took the middle term and said, you came from these two x terms. So negative 35x plus 4x does make negative 31. And we already figured out that in the end, it'll work with my first times my last. Grouping says, hey, just set them apart and ask yourself the question, what's the greatest common factor? A 7 is shared and an x is shared, so we pull them out. A 4 is shared, so we pull them out. And then if you have grouped correctly, these two will always match.
Yeah.
And since they match, we can look at this as two big pieces with a common factor that we can ultimately factor out. You can think of it as coming before and write these switched, or you can think of pulling it out this way. But you're factoring this one away. There's my x minus 5 factored out, and I have a 7x plus 4 left. If you want to think about it, this could also factor into the 4 and factor into the 7. But we have our final answer. And how can you always double check any factoring to make sure it works? Foil. First, outer, inner, last. You would end up with this, which would simplify to that. Check your done. Cool. So then, how would we do number 6? Oh, you don't need that for number 6. Let's keep going. Number 7. Let's do one more all together. Then we give you guys just a couple of moments as a group to do number 8. But number 7. We're just gonna do number 7 together. Some of you might have already gotten there. Most of you, though, were kind of like, yeah, staying away from those as long as possible. Number 7. Help me out. First step. See a number in front. Freak out for a little bit and then say, okay. Jason, what were you saying? Multiply 7 times negative 28. Ew, gross. I know, I hear you all on your calculators, but just in case, if you had to, 7 times 8 is 56 times, carry the 5. 14 and 5 is 196. There's a negative. Now, you don't necessarily have to write all the factors out always. I'm just doing it to make a point and say you can divide by 1, those won't add or subtract to be 45. You can divide by 2, 2 into 19. You guys know how I'm mental mathing this, right? I'm not just seeing it. Some people do that, and if you're one of those, props, hats off to you. I'm not. I do a little 2 into 19 is 9. Carry the 1, 8. I'm doing a little quick this in my head. 2 into 19 is 9. Carry the 1, 16. 2 into 16 is 8. Anyway, long story short. Not going to add or subtract to be 45. 3 goes in. 3 into 19 is 6. Carry the 1. 3 into 16, it doesn't even work. 4 into 19 is 4. 16. Carry the 3. 36. Ding, ding, ding. You see it? Which one's going to be negative, the 4 or the 49? 49 needs to be negative to make that a negative 45. I need to have opposite signs to make the negative 196. Now help me out. Where am I going next with these numbers?
We're splitting.
I'm splitting up.
With the 490.
Now, my strategy. If you have a negative and a positive number, always make the negative one go first. Reason being, when you go to group and factor out the common factors, if the negative's here, hopefully you're not going to mess up that sign. You're going to pull out whatever's in common, and you're going to keep the minus right where he needs to be. If the minus was over here, I'm a little scared you would mess up the factoring out. Because you would have to take a negative number out from both, and a lot of people get messed up there. So I like to write the negative one first if I have a choice, and go from there. What's the common factor of the next piece? Take out a 4. Did our grouping work? Yes. We have a common factor of x minus 7. Factor out the x minus 7. What do we have left? In case this works for you better, you can pull the x minus 7 this way like we always do with factors. And you can say, who's left once those are gone? 7x. Good? Ashley?
Can we put the 7x plus 4 first?
Either way. And why? Because multiplication is, what's that property where you can switch it back or forth?
Reflexive.
Commutative. Close. Be correct.
I tried.
Reflexive is A equals B and B equals A. But this isn't an equals, it's just commutative property, you can go back or forth. Alright, I want you guys to go ahead and take just 1 minute and try to factor number 8. You may work in your groups, you may talk in your groups, you may discuss in your groups, but please, please, please do number 8.
Oh.
And talk it out. If you can help in your groups.
Hang on, kids.
There's only 4. Take your time.
10 was juicy.
6 and 7. 6 and 7.
It's not 6 and 7.
I know it's not 6 and 7. I know it's not 6 and 7. Thank you. I just got there. I did. I was just look at the screen. Look at the screen. Yeah, I just got there.
Now do number 10.
I'm not doing it with 10. I'm doing what you're supposed to do.
Like, you're getting the factory okay, right?
What?
Getting the factory okay?
Yeah.
Okay.
What are you supposed to factor out, Tyler? Oh, wait.
Did you get cut?
That's really sad because
Dear Blake.
What's ball? Turn it to ball and calendar. It's like
Tyler, isn't number 10 just basically the same thing?
Yeah, I agree.
I'm gonna try it.
Gotta factor something. Hey, Caleb, you gotta factor something out.
It's B plus 7.
We were all thinking it. You gotta I actually know.
What did I not write? Something silly. Oh. See? Silly me. Thought he was the problem number. Makes so much more sense.
Yeah, but it keeps the ball so that you don't have to worry about it.
Crazy, but not impossible. Right? But yeah, he's a little crazy. Dun. Did you match?
Later.
Do you agree?
Lucas got the exact same thing. Maybe the two. Good job, David.
If you wrote it backwards, is it still okay?
Yes.
Yes! As long as they are the exact same factors, but if you wrote it in the other order, you're just as right as I am. Put this in the little pocket of your spiral. Hide it. You're supposed to finish the last 3 for tonight. But let's get back to our notes. Part of it. We still have our actual homework. Put it in the pocket of your spiral. It'll be right there. Isn't it so nice and organized? You'll do your homework. You'll have your worksheet. Oh my gosh. Just don't forget your spiral.
Well, honestly, not correct.
Tyler the God knows why.
You should get
End of degree.
fully factor means you have 2 squares which multiply.
Check out the backboard. Are you guys tracking? Here we go. Notes open. Calm. Safe place. And if it's not, make it safer than it is right now. Notes open, same section. On the backboard, we are finishing 2.1. We are still in 2.1. We have a couple technicality sort of things, technical things that we need to kind of iron out just a little bit. And then due on Monday, the rest of the factoring worksheet. We only have 3. 1 easy one, 2 kind of hard ones. But we've practiced hard ones. We have a system for them. Hopefully you're ready. But we're in our notes because we also have the homework for section 2.1 due on Monday as well. All right. As you guys are in your notes, you should see and be writing parabolas, yes? And you are writing, hopefully, concave up parabolas, or as the book would say, parabolas that open upward. and concave down parabolas, or as the book would say, open. Parabolas that open downward. How do we know, based on the equation or the function of a quadratic, whether it's opening up or opening down, whether it's concave up or concave down? Negative, positive, but what? Only of the leading coefficient. And that's what's written up there. Only of the leading coefficient. And technically, if you guys notice down below, I'm saying down here, A is greater than 0 or A is less than 0 because who is the leading coefficient? In the definition, it's A. Right? Or even in standard form, it's A. A determines the leading coefficient. A silly way of remembering it, if A is positive, concave up, I say like a cup, but I guess you could think like a smile, like a positive person has a smile. If A is negative, negative people frown, concave down to frown. Either way. Hopefully that's somewhat ingrained in your head, but what may not be ingrained in your heads yet is if a graph opens upward, which is a little bit weird. If a graph opens upward, it actually has a minimum. Which makes sense if you look at the graph that it has a lowest point, that's the vertex. But if you're just thinking about it, A is positive, concave up, it's a max. You're just like all the positive big things, right? But you have to think about the graph and say if A is greater than 0, you have a concave up graph which has a minimum, and if A is less than 0, you have a concave down graph which has a maximum. I don't know why, but for some reason this is kind of counterintuitive. So thinking about the graph, in my opinion, makes all the difference. And where do maximums and minimums occur? At the vertex. And if we're dealing with equations, we find the vertex with H and K standard form. Right? Axis of symmetry. He's just the line about which the line's not actually a part of the graph. It's more like an understood line about which we could fold and it would be perfect. When you guys were like in elementary school, or maybe when girls were in elementary, maybe the guys didn't do it. You would fold the paper and you would draw a half heart and then you would cut it out and be like, it's perfect, right? Same thing here.
Yeah.
That line, you guys don't really know, yeah. Not even for Valentine's Day when you were forced to, I don't know, never mind.
Most guys didn't do that. Most guys.
But if you fold it and you like trace the halves, right girls, that's how we make it perfect and symmetric. Same thing here, the axis of symmetry is the line about which you fold. But what do you notice about the characteristic, Elaine, a phone and a face? Both of those lines are vertical, and vertical lines have an equation of the form of calm. Okay. X equals is a vertical line, but question, what X does this go through? Hey, it hits the vertex randomly. What X does this go through? Hey, it hits the vertex randomly. The X of the vertex, which is just steal it, H. Right? It's always going to be that. You find the vertex X's, don't hurt yourself, Mason. H. That was rough. So how do we find the maximums or minimums? Just a quick little recap in case you haven't gotten it from what we wrote before. You find the vertex. Check the sign of A. And I would say visualize the graph. Maybe not the entire graph with like the specific points and the specific numbers and all this, that, and the other, but the shape of the graph as to whether it's concave up, has a min, concave down, has a max. Visualize that. I promise it will help. Why are we talking about maximums and minimums and axes of symmetries? Because in your homework, there are some that want you to end in sketching a graph. But in order to properly sketch a graph, they're going to ask you, find the zeros. From today, what do we do to find zeros? Factor. They're going to ask, find the vertex. From today, how do we find, and yesterday, the vertex?
You just do the complete
Complete the square, right?
Square.
And how do we find when they ask us the maximum or minimums,
Negative or positive?
it's the vertex, just think about the sign of the leading coefficient, right? Just think about the sign of the leading coefficient, and then you can identify which it is. And if they ask for the axis of symmetry, steal the H. So, if we end on this final example before saying, hey, homework. If they want us to identify the vertex and the axis of the parabola, which is the axis of symmetry, I'm going to put and the zeros because that makes life a lot easier. If they're there. Uh-oh, sometimes they're not. We would start by, maybe, if we go in order of the problem, how do we find the vertex?
Completing the square.
Completing the square. I'm going fast. You guys are all ignoring me anyway. Just kidding.
listening.
Nice.
Lucas is like, not gonna be ours.
4.5 is 2, 2 squared is 4. 4 is really an 8. Some of you might need to look back in notes and remember why. My vertex is going to be, question,
Negative 2, 1.
-2, 1. Is it a max or is it a min?
Minimum.
Why?
Leading coefficient.
And we'll keep going and put it all together in a nice graph, and you guys will do that homework. Bye, guys.
Miss Dewey,
Yeah,
why is it take away 8?
because the 4, when I put it in context, adds 8 to the problem.
So why is the 7 still like this?
Oh, he's still there.
Okay.
So we're just keeping him as our systematic approach, and we're adding, like, we're offsetting, and then we combine and say, is that cool?
Yeah.
Do, Kayla.
You dropped the pink pen on the floor.
Yeah, I see the pink pen.
Your calculators under your desk.